These two switches that I bought a year apart look exactly the same. The part number is identical and the boxes look almost identical. However, there is a small difference between the two. This one says cores for traffic prioritization. This one says static routing. This is the version 1. This is the more recent version 3. The question is, have we lost cores for traffic prioritization and gained static routing? Well, the answer is, well, no. A quick comparison of, well, in fact, a detailed comparison of the two specifications, they're identical. So what is going on here? So let's have a look at these devices in a bit more detail. Here I have not one, but both devices. So they're dimensionally exactly the same. Same finish. The fronts identical. The sides. And the back. So let's have a look inside and see if we can find anything. With the cover off, we can see that the color of the boards is different. The heatsink has changed. These transformers are different in the new board. But generally speaking, there's a whole heap of components missing here and here, 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 and here. And the reason why is this model, the SG2008P, appears to share the same board as a SG2010P, which is a 8-port PoE switch with 2 SFP cages. The memory is identical between the two devices. However, this flash here has changed. That's a GigaDrive. That's a WinBond. This Realtek LED driver has been replaced by these 4 here, which means that the way that they're driving the LEDs has changed. This power section here is identical to this power section. However, this power section is laid out different to this one. This one and this one look more similar than this one and this one. The ferrites here are no longer here. However, capacitors have taken their place, and the reverse protection diode is missing on both. So it appears that these two are identical, as the brains are the same. However, one's just a more cost-optimized version of the other. With this switch back together, we can add it to the Omada system. In the bottom right-hand corner is the light statuses of the device itself plus port 1, and it is currently powered off. And what we're going to do is power on the device, see it boot up, appear on the dashboard. We'll adopt it and do some basic configuration. One of the benefits of having a controller-based network. So I'm just going to off-screen plug it in. That's the device powered on, and we should see it start to now boot up and become ready. We'll just head up to the devices tab here, and we should shortly see the switch appear. The device will be doing a power on soft test, and then a link light will appear, and then it'll do a discovery or start to reach out and see if there's a controller. The controller will recognize that and display it up here. We have a link, and shortly the device should appear here. Here we go. The device has now appeared in the device list. This is the base MAC address, its current IP address. It doesn't have a public IP address. It's in a pending state, the model and version, the uptime, and what we want to do is adopt this device. So just here, we'll click adopt. And that's now going to configure the device with some basic information, such as the local username and password, which is defined in the global variables of the controller. And we're now connected. We can now begin to change the configuration of the device from default to what we want. So we'll remove the name it was given and give our own. So it's switch number 2. Apply that. That's updated. And now we just need to present some of the networks to the uplink of this switch. So we'll just go to settings, wide networks, LAN, and just going to present some of these on that port, which is port 1. Save that. And we only need to do this for the networks which are not the default one, which is this MGMT one here. And that's all the networks presented on that port, which uplinks to the switch, and we can then use those VLANs on any of the downstream ports. One of the benefits of having a controller-based system is that all the devices are visible in one quote-unquote single pane of glass, and here the dashboard, or the controller, shall I say, has periodically done a check of the available versions of firmware for devices. Our new device has a new version of firmware available. Clicking on the link shows us the fixes that are available. Click on upgrade. Easy enough. That controller will now download that firmware from the internet and upload that to the device, apply and reboot. And the device is now being upgraded. We're now running the new version, and the device is currently just being provisioned by the controller. The uptime has reset as the device does reboot during upgrade. And now it's just being configured. And we're back to a steady state now where all devices are connected on the new version. And switching over to the map, we can see here our topology is the existing switch and gateway connected to the internet. And hanging off this gateway here, we have our new switch, which we can then use to connect more devices.